Okay, hello. Good, you can hear me? All right. So, my name is Rafael. I'm currently a postdoc on the computer science department of LNU in the ISOFIS group. I work with Professor Andreas Karen, and he unfortunately couldn't be here today because he has a very important meeting in another research project that he's leading. And it's a meeting that's been scheduled for some time now, so he couldn't change it. Then he asked me to come and speak in his place. So I will try to give a very quick overview of what we do and what we will do in this LNU Center project, because we have this LNU Center project number 3, Visual Analytics for Engineering Smarter Systems. So just a very quick overview of what we intend to do. Motivation. Of course, you have heard the words big data today a million times, and probably you will hear a million more before the day is over. So we know that it's not a new problem. It has been called many different names, such as information overload problem or very large data sets or anything. But the problem is the same. We have data which is stored without filtering or refinement, so we have lots of data, and it's an exponentially growing problem. So there are sources that say that 90% of the information that was ever created by human beings was created in the last 2 or 3 years. So it's exponential. It's still growing, and the problem is raw data has no value, right? So time and money are wasted storing and extracting all these data, but when you don't do anything with it, this data might as well not even exist, because economically speaking, it doesn't mean anything, and you're actually losing money instead of making more money from it. So, of course, it's a big problem, and there are a few important questions related to this, such as how to make use of this data, and who defines the relevance of an information? Who or what defines it? Because it is very common to think in terms of, for example, machine learning. Okay, so that's something that's very also current right now, with companies such as Google and Facebook really pioneering on applied machine learning, really using machine learning in our everyday lives. And but what does that mean? When you use machine learning, you have most of the time automatic solutions. So a machine learning solution will create a model, will analyze your data, and will give you something very easy, like yes or no, or the favorite product of this person is X, and maybe he also wants to buy product Y or something. So that is, yeah, that's cool, that's nice, that's very interesting, but the truth is, the human beings, when the real decisions are being made, when the real strong points must be made, the human beings must be involved, okay? So that's when we think about what kind of visual representations and interaction techniques can facilitate problem-solving and decision-making. So this guy over here is with his big eyes. What he's telling us is that vision is still the human sense that has the higher bandwidth. So by looking at something, we acquire data very fast. Of course, it's just not by looking. You don't acquire data from anything just by looking at it. You need good views. But still, vision is the way we acquire data faster, so we must use it. And that's where visualization comes into play. I like to show this very small example for you, which we call Anscombe's quartet. It's interesting just so we understand this interplay between, for example, machine learning and visualization. So we have this 4 distribution of data points, and you can see down below that their mean, their variance, and their correlation is exactly the same. So there are 4 different distributions of points, and if you look at them from an automatic perspective, like statistics, such as mean, variance, and correlation, they are exactly the same. And they even have an identical linear regression, But when you put them on a very simple visualization such as a scatter plot, like this, like what we have here, you can see, you as a human being, can see that the 4 distributions of points are completely different. But the computer could not see that. I mean, of course, it could if you teach it to do that. But just thinking about some very simple statistics, a computer could not tell the difference between these 4 different distributions of points. So this is just a very simple example to show why visualization is important, because we still can see more than the computer can. So, of course, then comes into play information visualization, which is interactive visualization methods. Everybody has been talking a lot about visualization so far. Every project has mentioned visualization at least once. And the truth is that when it comes to big data, visualization is not enough. We call, in the visualization area, we call it real estate. We don't have enough real estate to just show all the data when it comes to big data, when it comes to billions of data records. Visualization is just not enough. For example, we've been talking a lot about Twitter here, and I see that everybody's interested in that. So I just put some very simple examples of visualizations of Twitter data. And this is, for example, I don't know if you can see it very well, but anyway, this is tweets from public relation people in the UK and their followers. So you can see that when the numbers start to grow, visualization itself, by itself, is not enough. I mean, you can see lots of stuff, but do you understand what you're seeing? It's not easy. This is also very interesting visualization of a Twitter data set. So this is about when there was an attack in Gaza. And then these are the tweets that were broadcasting the news and everything. They were trying to spread the word. And also, you can see it's very nice, it's very beautiful, but how can we really understand such a thing? I mean, it's very big. There's a lot of information, right, in this picture. And this also is, this is from Instagram, and they're trying to map cities by looking at the pictures that people post on Instagram, and they're trying to analyze these pictures and map the structure of the cities. But anyway, these are just very quick examples to show that visualization by itself is not enough, okay? We don't have enough real estate in the screen, like pixels, to show everything. So we need to mix it with machine learning in a way, and that's when it comes, visual analytics comes into play. So visual analytics is the science of analytical reasoning facilitated by interactive visual interfaces. So I have no idea how much time I'm spending, so when I have like 5 minutes, you show me. 6 minutes, all right. So, and then what happens is that we must start to think about interaction. So we need to put the human in the loop. It's not just like, well, computer, tell me yes or no. It's not like that anymore. So you need to analyze the data. You need the computer to filter it. You need it to model the data. You need to create a more manageable subset of this data that makes sense. But you still need the human in the loop. And that's when we come into visual analytics. So it's information in scientific visualization, HCI, it's human-computer interaction, data mining, data management, and so on. So visual analytics is used to synthesize information and derive insight from massive, dynamic, ambiguous, and often conflicting data. We had our friend from Tunga. He said that they take data from different sources. So when you take data from different sources, you can't just throw it into the screen. You have to filter it. You have to merge it. You have to do stuff like that. And just one thing that I want to keep from this slide is detect the expected and discover the unexpected. This is a trademark from Jim Thomas, which is a very important researcher in this area. So detect the expected. See what you know is on the data. And after that, you want to discover the unexpected. So you need to see something else. You can't see just what you're expecting to see. The visualization must show you something new, right? And then finally, support decision making, because that's the point. The humans must be in the loop, so it must be interactive. You must talk to the data and then find something, but the decision is yours. The computer is not going to tell yes or no. You are going to say that. And then that's a mantra. I'm going to speed a little bit because I don't have much time. But so we have this project as visual analytics for the engineering of smarter systems. The aims of the project are to generate new knowledge, to better understand and engineer complex cyber-physical systems. So we have lots of data. Data is coming from sensors, from machines, from whatever it is that any one of you have in your day-to-day work. And we want to understand that and then use that understanding to engineer better systems. So we want to increase performance, guarantee reliability, better prediction, control the behavior of the machines or something. And we generate knowledge based on this cycle of visual analytics. So I'm also not going to spend a lot of time on this, but it's basically you get data, you model the data, you visualize this model, and then you improve this model by the understanding that you extract from what you're seeing. So you see that visualization is trying to show you something. And then you have to use that knowledge, and by interactive tools, you can improve on that knowledge. So one thing that we want to make very sure is that we are willing to develop foundational visual analytics principles, techniques, and tools. So we want to make excellent science. So it's not just about developing a system that will monitor some machines. We want to talk to you, we want to know your problems, and from those problems, we will think of scientific solutions that are novel. So we will push the boundaries of the scientific knowledge and not just develop something to control or to monitor the machines, right? So this is very important. We want to really do something new. The systems domains and data providers are not yet defined, so they're still open. Some examples are, for example, power grids and vehicle fleets, like our friend from Tuga gave the examples of the vehicle fleets and the monitoring and stuff. Depends on the scientific challenges, the tasks to solve, the domain experts available. So we want to invite you for a kickoff meeting in January 2017. We want to talk to you. We want to know the problems that you have, and then we will discuss that and see how we can merge these two interests, your interests, our interests in the scientific knowledge that we can generate, and then we can define something to come from that. So please, if your analysis problem fits into the scope, contact us. This is the email from Professor Andreas Kering. He's the leader of the project. He's probably the one, the first one you should contact if you have any ideas. And then even if your data or analysis tasks are not exactly fitting into this, still, if you have ideas, come to us. We can talk about future proposals and for external funding around InfoVis, visual analytics. So we're open. We have this group, and we want to talk to you. Thank you.
Thank you very much. All right, time for questions.
Hi.
Hi.
Very good presentation.
Thank you.
Do you have some existing libraries that, for example, doing some visualization in mobility data analytics or smart transportation analytics? So is there something that exists today to solve some existing problems? Or if some companies need to get help from you,
yep.
Then they need to look it from very, very, very early stage. That means that you want to define problem, define what kind of visualization libraries required, and then you will develop libraries. So what's the way of thinking regarding solving some real-world problem?
All right. Thank you. Yes, there are a million different visualization libraries that you can find on the internet for all programming languages, for all environments, and for very different tasks. But this is not the goal of this project, obviously. The goal is that we will have a scientist working on it full-time, so a PhD student or a postdoc, and we will think about novel things. We will not just say, oh, no, you can use such a library for generating a graph visualization. I mean, if that solves your problem, if generating a graph visualization solves your problem, then that's it. It's not really what we're focused. We're thinking about more complex problems that can be solved, that have to be solved by more sophisticated approaches. So maybe we use a library, maybe we don't. But even if we do use a library, then probably, and I mean, absolutely, for sure, we will have to customize it and make it do something that it doesn't do right now. Because if there is a solution for this, if you can just use a library and solve this, then that's probably not the kind of problem that we should be working on right now. So the idea is that we talk, we understand the problem, and we think about a new way of solving it. Okay?
So maybe I can answer your question. So and thank you for it was a good answer. So just to make it clear, when we say doing research in visualization, it doesn't mean that if you published a paper and you have a visualization, it is a research in visualization. So as Rafael said, it's having, if your data is simple, let's say in a way, or the tasks you want to do with the data are simple in some ways, you can use Tableau or Spotfire or any of the other tools, or even Excel, and export the visualizations. And in some cases, that's enough what you need. But when dealing with big data, that's usually not enough, because most of the tools that are there don't really scale. And it also depends on the tasks. So you have, for example, in social sciences, you have networks. You have networks in biology. If you think conceptually, they are both small world networks. And you might say that, okay, I can apply the same set of tools to analyze both networks. In some cases, you might be correct, because you can use, for example, network centralities, and you might identify interesting actors or important actors in both networks. But if you want to do a specific analysis, you have to develop specific tools, like you would develop specific computational tools to tackle specific problems. You have to develop specific visualizations to tackle specific challenges. And that's where it's interesting for us as visualization experts to do research. Otherwise, from a research point of view, it's really not something that's so interesting.
Exactly. And usually, if the problem is complex enough, the tools that exist, they are not enough. Because if they are, then your problem is already solved in a way. So okay.
Okay, one last quick question or comment.
I mean, I agree. But the problem is here that we're thinking to help companies. And companies don't care, is it a research problem or it is some other kind of problem. They need solution, right? That's the one thing. And the second thing is that visualization sometimes comes after analysis. That means that how you want to convey result to your managers or the people who don't talk with numbers. For them, it's more important than just like statisticians. They might understand numbers very good, but decision makers, they need support for that.
Of course, yeah, of course.
And on that kind of problem, or those companies who have that kind of goal or need, for them, what you want to offer?
Okay, again, I think it's still the same. We have our proposal for the LNU Center. It's a proposal for a research center. So this specifically is about doing research and doing novel research. So we are looking for big data problems that are not solved yet. And maybe, like you said, maybe for the company that has a simple problem just of presenting some data, then we can talk about that, but maybe this partnership may not be the best solution. Maybe the best solution is to use Tableau, okay? So in that case, yes, but, yeah, I don't know.
We are running out of time. Could we? All right, go ahead.
Do you need to know the problem, or is it enough to come to you with a type of data and figure out
It helps a lot if we have some proposed task that you want to do, but often and most of the time that doesn't exist. It's common. So that it's also interesting for us to have data, and then we can, because sometimes you can learn more about your data by looking at it in some way, and then you can come up with a task after that. So, I mean, if you have a task, it's perfect. But if you don't, then we can still talk and see what we can do, yes.
Thank you very much again for the
Okay,
session.
thank you.